Hi guys, in this video I'm going to start a new series. We're going to build a bigger app than anything we've built so far. And I also want to use this to go back and revise some of the really basic Java concepts which we've covered earlier but which not everybody has completely absorbed at this stage. And I also want us to introduce some new stuff in a practical context of building a complete app. So the app that I want to build is going to be about the monarchs of England. I got this picture off the internet which has pictures of different monarchs. And what we're going to do is we're going to create an app which has a list of monarchs. You can click on different monarchs. It's going to show you the picture. It's going to tell you information about them. And there could also be a test function where it will test you on your historical knowledge. So this is going to be a relatively big project, but in this lesson we're just going to focus on the issues about how to model that data. Okay, so particularly we're going to think about how to store the data for individual monarchs in Java, and then how we can retrieve that data. Now, this is where the concept of classes is really important. So we have talked about classes before, but it's definitely something that we can go back and revise some of the terminology about. It's an important topic, not just for your internal assessment, but there's going to be lots of questions about this kind of stuff on paper 2 of the exam. So if we think about the concept of a class, a good way to explain what a class is that it's a way of organizing data and the actions that you can perform with that data. So if I want to store data for all of these different monarchs, then each monarch is going to require the same information to be stored about them. So it's kind of like we can imagine each monarch fills in a form. Okay, and that form is going to contain the information we want to record. So what's going to be on that form? Well, we want each monarch to enter their name. We want to have the gender. We want to have the first year of their reign. And we want to have the final year of their reign. So you can imagine like printing out these forms on a piece of paper and giving one of these forms to all of these monarchs, if they were all alive, of course. This is just a thought experiment. And then each monarch would fill in the details. Now that's basically the idea of a class. Okay, so a class is a description of the form which is going to be filled in with data. So the class is like the form, and each form which has been filled in with the data for an individual monarch creates what's called an instance of that class. So if I had a class which was monarch, then I would have a different instance of that class for Queen Victoria, for Edward VII, for George V. Each of those would be a different instance of the same class. So we could have, in this case, Queen Victoria, Edward VII, George V. Okay, those are all instances, and then the class would be monarch. Okay, so let's implement that in Java. I go over here, I go to my monarchs package, go to new class, and then the class, beginning with a capital letter, is going to be monarch. Now in the monarch I want to have the name, and that's going to be of type string. Now I want to have the gender. Now I think a good way to store gender is with a boolean, because there are only two genders. So a boolean is either true or false, and the way that I would store that is using a name like Ismail. Now the reason I'd pick a name like isMale is because it tells you what true means. So if the value is true, that means it's male. If the value is false, that means it's female. You could do isFemale just as well if you want to flip the values around, but the important thing is that the name of the variable needs to say what the true value indicates. Okay, now we also need the start year, and that's going to be an integer. And we want the end year, and that's going to be an integer as well. So these are the 4 items of data that I want to store for each monarch. Now, those 4 items of data, when the class is first created, those are going to be empty. So let's have a demonstration of that. I'm going to write Monarch, and let's do, I don't know, let's do Victoria. So Monarch Victoria equals new Monarch. And then what I'm going to do is print out the year that Victoria ascended to the throne. So start year equals plus Victoria dot start year. So this is going to get that start year from the monarch that I created. So this is where I create the monarch with the keyword new. Okay, so new will allocate some memory to store a monarch. And in this case, I've called that monarch Victoria. Now that is the name of the variable. It does not mean that this value of name is going to be set to Victoria. Okay, this is just the name of the variable where I'm storing that data. And if I run this program, you'll see that the start year is 0 because I haven't actually put any data into this memory. Okay, I've said that the variable exists, but it's just empty at the moment. It's the same if I want to print out the monarch's name. Okay, even though the variable is called Victoria, if I try to print the name, it says null, and that means no data because I haven't actually put any name into that variable there, that data item. So the first thing we've got to do is find a way to get data into these data items. Now, one way would be that I could actually write, for example, Victoria.name equals Victoria, like that. But this is a bad way to put data into a class for reasons that we'll see a bit later on. So normally, if you want to get data into a class, what you do is you create a constructor which will pass data into the class when it is created at the very beginning. Okay, so when I create a new monarch, I'm going to require some data to be provided. Now to do that, I go to the monarch class, and I'm going to start creating a constructor, which I do by writing the name of the class first. And then in brackets, I'm going to write the things which I require when the class is created. So I need to know the name of the monarch. I need to know whether that monarch is male. I need to know the start year of their reign, and I need to know the end year of their reign. Now, this information, I've chosen names which match the names up here, but that is not necessary. Okay, so this information is being provided, but at the moment I'm not doing anything with it. Now what I want to do with it is to copy the data which I get here into here. And I can do that by writing this.name equals name. Now this dot means the value inside the class monarch. So when I write this.name, it means that name. It doesn't mean that name. If I don't write this dot in front of it, then name means that name. So what I'm doing is I'm copying that value into that value, because that name refers to that, and that name refers to that. It might be easier to see that connection if I change the name. So if I call this name 2, now you can see that that and that are the same, and that and that are the same. Okay, and this is just moving the data from here into here. Now, although that makes it clearer, I personally like to use the same name here as here because I just think it makes it look neater. So now I'm going to write the same for the other variables. Now this is a really common pattern, and I'm sure you're going to see something like this on the exam paper 2. Now sometimes on exam 2, the paper 2, they won't use this dot. What they'll do is they'll use different names. So for example, instead of end year, they might say final year, and then in that case you don't have to write this dot, because Java can tell that if you don't write this dot, you just write end year, but there's no end year here, so you must be talking about the end year here, and Java can work that out, and that means that this dot is optional. But you can always write in this dot, and personally I like to write in this dot to make it clear what the meaning is. But be aware that on the exam paper they may not include this dot, they might just have a different name here, and you need to be able to understand that even if you don't write it yourself. Okay, so we've written a constructor which means that when you create a Monarch you have to provide these 4 items of information. Now if we go back to main, you can see that it's now complaining because it's saying I've got to provide that information, and so far I haven't done so. So let's provide the information that's required. First of all, I provide the name, Victoria, in quotation marks. Then I provide the gender, so that would be false in this case since it's a female. Then I provide the starting year, and I think that was 1831 for Victoria. I'm just going to check that. Was it 31 or 37? 37, sorry. 37, and then 1901 was the final year, I think. Okay, so now I've created a new Monarch, and I've made sure this time that the Monarch gets all of the data it needs when it's first created. So now if I try printing out the start year for Victoria, it correctly says 1837. Now, let's say that I print not the start year for Victoria, but just Victoria. So I want to print that object on the screen. When I run the program, what I get is this. So I'm just going to change this text here. Let's just print the object. So what I get is this, and this can be useful sometimes. What it's telling you is that we have an object. The type of the object is Monarch, which is inside the package Monarch. So you can see there's Monarchs and there's Monarch. And this number here is a memory address, which is basically just telling you where in memory the object is. And that can be useful because it allows you to tell different objects apart if they have different memory addresses. But what we really want to do is that when we print out an object, we want it to say, that's Queen Victoria. Now there is a way to do this. What you have to do is you go to the class and then you write a method called toString. Now toString must always have the word public in front of it. So we write public string, capital S, toString. And what this is saying is that there is a method called toString. It's going to return a string, and the public is something that we'll have a look at a bit later on. So let's try returning the Monarch's name. Now when I try to print out a Monarch now, it will detect that we have a toString method for this class, and it's going to call this method in order to get the text that should be printed on the screen. And in this case what I've done is return the name of the Monarch. So when I run it, instead of printing that, it prints the Monarch's name, Victoria. So this is definitely an improvement, but what I would like to do is to print Queen Victoria. So we can do that by using an if statement and checking the Boolean value is male. You might want to try doing this yourself. So you could pause the video now and have a go if you want. Okay, and here's how I do it. So I just write if is male, then I'm going to return king plus name. And if it's not male, then I'm going to return queen plus name. So I'm just using the is male field to work out what title I need to provide. So let's try running that. Okay, and now you can see it prints Queen Victoria when I tried to print out that monarch. So this class is pretty useful now. It means that anytime I want to create a monarch, it makes sure that I provide all of the data that I need to provide. It stores all of that data in memory, and it also means that if I want to print out the monarch, it's going to print out their name with the correct title at the beginning. So you can see that this is a good way to organize stuff. Okay, this is called object orientation. This is the idea of object orientation, is that we have data items stored inside a class with the actions that we can perform on that data. So let's say that I want to define a new action. I want to have a way to tell how many years they were king or queen. So I'm going to create that action. That's going to return an integer. So I'll write int, and then the name of this is going to be length of reign. Now the length of the reign, obviously, without knowing the day and month, I can't get it exactly, but I'm just going to do a simple calculation of the end year minus the start year. So I'll do return end year minus start year. So this means that whenever I want to know how long someone was king or queen, I do length of reign, and it will subtract the start year from the end year and return that as an integer. So let's test that out. I'm going to say Victoria dot length of reign. Now when I do this, it's going to perform that calculation, and if I run it, it says 64 years. Okay, which is, I don't know if that's actually correct, but certainly that's 1901 minus 1837. So whether that actually is 64 years depends on the month and the day that she became queen. Okay, so you can see that we can add all sorts of methods which do different work with the data that we've got here, right? And in this case, this is a really simple formula, but we could create methods that do all sorts of jobs. Now, what about if I had a method which was to calculate, how about if I didn't want to store the start year and the end year, but instead I wanted to store how many years they were a king or queen? So maybe I get rid of the end year and instead I store num years, which is the number of years that they are on the throne. Now, if I change the way that the data was stored, I can still work out everything. I can still work out the end year because it's just start year plus num years. But the problem is that this is going to change a lot of my program code, because now I have to have num years in here, and then end year here is going to have to, well, I suppose I could calculate it here, end year minus start year. Num years. Now, just like I said in the exam, if I don't need this dot, then they might leave it out on the exam. And here I don't need it because end year and start year are provided here, but num years isn't provided here, so I don't need this dot for num years. So I'm going to leave that out so that you can get used to seeing it. Okay, so here I've got start year and end year, but instead of storing the end year directly, what I'm doing is I'm storing the number of years that they were on the throne, and then I can return that as the length of reign. So this should work exactly the same as before. What I've done is I've changed the implementation. Okay, so the class that I've got works exactly the same, but it does its job in a different way, because instead of storing the start year and the end year, it now stores the start year and the number of years. Now, that ability to change the way in which a class does its job is a really important aspect of object-oriented programming. Because in the real world, quite often you could have different programmers working on different parts of the program. And if one programmer wants to change a class that they are working on, then we don't want that to negatively affect other programmers which are working on other classes. So that means that changes to things which the class does should not affect other parts of the program as long as they achieve the same goal. Now, the way that we would talk about this in object-oriented programming is that each class has a contract. And the idea of the contract is that you're guaranteeing that the class will perform certain functions, but you're not saying how the class is going to perform them. So it's kind of the same as you would have a contract with an employee in a business, right? The contract says that the employee will do a certain job. It doesn't necessarily say how they're going to achieve that. And a class is exactly the same, that as long as the class fulfills its contract, as long as it does all of the things it's supposed to do, the way in which it does that should not be important to any other classes in the program. This is a really important principle of object-oriented design, and it's how we're able to produce very large programs with lots and lots of different programmers. So in order to have lots of different programmers working on the same project, we have to minimize the amount that programmers have to know about what all of the other programmers are doing. And using contracts for each class, and that means guaranteeing the things which are essential for the class, but not revealing any information which is not essential for the class. That boundary is really, really important. So at the moment, there's some information about the class which is kind of leaking out of this class. So for example, if I wanted to print the start year of Victoria's let's print the length of Victoria's reign, okay? Maybe instead of doing length of reign, I might be tempted to write num years, okay? Because we know that num years stores how many years Victoria was the Queen. And that will work. That will print out the same value, okay? You can see it says 64 for both. It says 64 for that, and it also says 64 for that. But I don't want people to use that. I want people to use that, because that is the correct way to find out how long a king or queen was on the throne. So what I do is I go back to my class, and then where it says num years, I write private in front of it. Now when I save that back, you'll see that I suddenly get an error here, and if I hover over it with Eclipse, it says that field is not visible. So what that means is that although the field does exist, it should not be accessed by any other class. Basically, that data item there exists for my benefit as the programmer of this class, but programmers working on other classes should not be able to use it. Now that's really useful, because it means that, let's say I want to go back to using end year again instead of num years. I can do that and change this back to end year, and I know that I'm not going to break any of the other code in the program when I do that, because I know that nobody could be accessing end year. If they tried to access, if they tried to access num years or end year, it would have given them an error. So I know that that's not happening. So this use of the word private is something really important that that can allow us to prevent other programmers for depending on details of our classes, which we don't want them to depend upon. Okay, so it's basically separating the things which we're willing to share with other programmers and the things which we want to keep private to ourselves. And I'm going to put that private in front of all of these data items, because if a programmer wants to know the start year or the end year or something like that, what I'm going to do is provide a method for them to find that out. I'm not going to allow them to just come in and access the data directly. Okay, so now what we have to do is we have to create methods for that information. So let's say that a programmer does want to find out the name of a monarch. Well, that's fine. What I'm going to do is I'm going to say that if they want that, they just have to say get name. Okay, so get name is a method which is going to return the name of a monarch. Now, I want any programmer to be able to do that, so I'm going to use the opposite of the keyword private, which is public. So this means that any programmer can get the name of the monarch, and if they say get name to a monarch, then it's going to return that monarch's name. And also length of reign, yeah, I'm going to let any programmer access that, so I just put public here. Let's create some more methods. So I'm also going to let any programmer find out whether the monarch is male or female. So I'm going to write public boolean get is male, return is male. Now I'm going to do one for the start year of the reign. So public int get start year, return start year. And for the end year, public int get end year, return end year. So you might think that I've basically spent a lot of space writing some completely useless code here. Why didn't I just let programmers directly access that data? But there are some advantages to doing it this way. So the first advantage is that programmers can get the data, but they can't change it. So if these weren't private, then it would actually be possible for a programmer in another class to change some of these values. For example, let's make start year not private. Now I could change the value of Victoria's start year by just storing another number there. Let's say that I wanted her to start in 50 BC, right? So minus 50. Okay, well, that's possible because start year isn't private. And if a programmer did that to my class, it's going to really mess up all of the calculations. So I just don't want to let people do that. So I'm going to make this private again. And now it's no longer possible for other programmers to change the start year. But they can still find out what year she did become queen by just doing Victoria.getStartYear. Okay, now this type of method where we create a method that just returns data which is private is called an accessor method. Or sometimes as slang we call them getter methods because they always begin with the word get. So if you have a variable called name, then the getter method or the accessor method is called getName. If the data is called isMale, then the accessor or the getter method is called getIsMale. Now, writing accessor methods is so common in Java that there's actually an automatic feature in Eclipse to do it for you. If you go to source and then go to generate getters and setters, and then choose select getters, and it would just create select get Okay, hold on. Oh, it's because I've already written them by hand. Let's delete the ones that I've written by hand, and then I'll go to source and generate getters and setters, and then I'm just going to select all of the gets, and you can see it generates them for me. So this is something that's extremely common in Java. It's also extremely common on paper 2 of the exam. So you're pretty much guaranteed to have to write some accessor methods. Now, if you want to let a programmer change data, then you create something called a mutator method, which basically works the same way, but it allows you to change a value. So for example, let's say that I wanted to have a way for programmers to change the name. I create a mutator method called setName, public void setName, string name. And that's going to change the value of the name, so this.name equals name. Now this makes a pair, right? So we've got getName, which will return a string, and we've got setName, which takes the string and doesn't return anything. So if I wanted to change Victoria's name to Barry, then I could do Victoria.setName Barry, and then if I run it, if I print out just Victoria on her, print out that object, it's going to say Queen Barry, okay, because I changed that name. Now, of course, I don't want people to change the name. They've got no good reason to change the name, and we shouldn't allow other programmers to do things which they don't have any reason to be doing. Okay, that may sound really prohibitive, but this is, we have to maintain very strict order. As programs get larger and larger, if you want to keep things under control, then you have to be very, very careful about what you let other programmers do. And when I say other programmers, just to clarify, quite often other programmers is actually you, but at a different point in time, right? So when you come back to your program a little bit later on, maybe even just in an hour's time, it's very easy to do something stupid with the code that you wrote earlier. So it's just as much about protecting you from yourself as it is protecting your code from other programmers, or other programmers' code from you. Okay, so guys, I think that covers the really important points for this lesson about creating data structures and creating accessor and mutator methods. The topics I've covered in this lesson are really, really important topics. They do come up, not only are they very important in the internal assessment, but they also come up very regularly as some of the easy questions on paper 2. So you must make sure that you understand what a constructor is, what an accessor method is, what a mutator method is, what a toString method is, what a class is, what an instance is. Okay, those are all really important, and you also need to make sure, we'll look at this a bit more later on, but it really helps if you have some idea of how private and public work. So private we use to hide things from other programmers, keep data private to this class, and public we use to expose things to other programmers so that they can access data or methods from other parts of the program. Okay guys, I hope that all made sense. I know this is quite a long lesson and it's really an exercise in the theory, but the stuff that we've written here is actually going to be part of our full app when we go on to build that a little bit later on.